Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in the D programming language series. In this lesson, we're going to be talking about structs. We're going to continue our discussion about how to build up structs using what are known as constructors. So again, if you're coming from different languages like Java or C++, you're probably familiar with the idea of constructors. But we're going to go ahead and look at them from the D perspective and pick up a few things. With that said, let's go ahead and take a look at the D programming language. Now, previously, I just want to do a quick recap of what we learned in the following lesson, and then we'll go ahead and look at constructors in the D programming language. So if you didn't see the last lesson, here's a quick review where basically we saw how to create this vector object here and how to explicitly initialize its fields. And if we default initialize this structure, well, we saw that it'll print out the explicitly initialized fields here. Or if we don't explicitly initialize them, we'll have the defaults, which for float is not a number, or nan is what's going to be printed out. And then we saw we get struct literals, for instance, for free, which is a really nice feature of the D programming language. Or even better, we can use static initialization for the naming of our fields in case we reorder these particular fields here. So I'll just go ahead and run this really quick so you can go ahead and see what we have in the code, and there's the result here. Now, what I'm going to go ahead and do here is take a look at the D programming language documentation here, and let's go ahead and look at constructors. So I'm going to go ahead to the documentation. Let's look at the language reference, and let's go ahead and go to structs here. And then we're going to go ahead and look at struct constructors down here. So let's go ahead and take a look here. I'll make this a little bit larger here. Let's find struct constructors. There we are. So what is a struct constructor? Well, again, it has to deal with how we initialize or create an object. So we have a few different ideas that we've explored here, like static initialization or struct literals that were a way to sort of fill in the values here. Okay, so again, at the code that we're looking at here, let's get it all on the screen here. We had these struct literals which could populate each of the fields here. But sometimes we need to do a little bit more work, right? We might want to call some function, calculate some result. So something beyond just putting in values in here that might not be our defaults. So let's go ahead and create a constructor and see how this changes our code. I'll make this a little bit bigger so it's easier for you to read. But in order to create a constructor here, and usually I do that under my fields here, which I've initialized with some values, we just use the this keyword. Now this you might be familiar with in C++ or Java, for instance, but this is the constructor here. It's not the name of the type here, as you've seen maybe in other languages, but it's just called this. And this is the constructor in Dlang for our vec3 data type here. Okay. Now the idea here is if I create a constructor, I need to supply parameters to it. So let's go ahead and provide some parameters like this, float x, float y, and float z. And then I can again use this .x, which refers to this member field here, and set it equal to the parameter here, which is referring to this argument here. And that's what we also use the this keyword to refer explicitly to this object, the field here. The other use, again, of this is for the member function name here, or our constructor. Okay, so that's the idea. Now, sometimes you'll see folks also do something like this, maybe give a different variable name here. So I could also say x, which is referring to here, is equal to the underscore x. Either convention is fine. I'm going to go ahead and just show you the this here with the dot syntax here to access each of our members, because I think it's just a little bit more clear of what's going on here. Okay, so this is an example of our constructor. So we defined a constructor in which we'll pass in all three parameters here. So let's go ahead and look at our code now and see that if I go ahead and run this, well, we're going to get a few errors now because we've defined a struct constructor that's telling us explicitly how we want to initialize this object. So let's go ahead and parse through these errors and just try to understand a little bit how structs are constructed. So the error message that we get here, if I run this, is that vec3 has constructor cannot use initializers. Okay, so it looks like here at line 35, I lose this power for this syntax here. Okay, I can't do the named fields here. So let's go ahead and get rid of it. Okay, so I go ahead and run this here. And let's go ahead and get rid of all that. There we are. And now we can see that this code works. Now there's one little caveat here where previously we had struct literals. So let's see if those are supported when we have a constructor. For instance, if I just initialize 2 of the fields here, well, no, at this point we don't have a constructor. We've defined the one way to construct our object, so we can't do this. We need to provide all 3 fields here. So let's go ahead and just change this to call our struct constructor. I could do 3.0f here just to delineate. And now if I run this code, it'll work here. Now, interestingly, what we see here is we can either make a struct of our type vec3 here by calling the constructor explicitly. And sometimes when I'm learning these things, I just like to put in explicitly called constructor with, let's say, x, y, and z here. And we know that constructors are just this keyword. So let's go ahead and put that in just so we can see which one was called here. And then we still have our default initialize struct here. Okay, so we could do something like b0 equals a vec3 like this. That also still works, but it's not calling our destructor. It's just default initializing all the values in here. That's effectively just the init properties. So for instance, let's just go ahead and do a right line here. The vec3.init, and I'll put a colon here. And let's see what this gives us here. vec3.init, so we can see the properties here. We can see that vec3 init is just with 0, 0, 0. And that's what we get here with our default initialization here. And we're just being very explicit to call the vec.3init with this syntax here. Okay, so that's the idea, a few different ways to initialize or construct our structs. Now we can do some other interesting things here. For instance, as mentioned, as soon as I define a constructor, we lose some of that ability to have our struct literals. And let's go ahead and just try to create some other constructors here. So let's just try to create an empty constructor here in the D language. And if I go ahead and run this, it's going to complain about this. It's going to say something about, well, default constructors for structs only allowed with @disable. Okay, so that's curious here. So you'd actually have to put @disable this here. And the reason for this is, well, if I have a default sort of constructor here, these are value types. So this is similar to other languages like C#, for instance, where we would just want to be able to say, since this is a value type, we don't need any sort of construction here, okay? So we're using constructors when we have other work to do, maybe to print out some messages, maybe we normalize these values or something for our vector, or just do some other work here, okay? That's where you want to use struct constructors. Otherwise, you can just rely on, if you have a simple type like a vec3, for instance, just explicitly initializing the fields here. You might not need a constructor. But even for a type like vec3, I still might define various overloads for this. For instance, I might just have a value here. And let's go ahead and try something like this here. Let's go ahead and initialize one value. So this will, well, here's my current claim. Initialize one of the fields. Okay, so let's go ahead and see if that works. So this time I want to call another struct constructor. Let's call this vec3 v1. And we want to call explicitly the constructor that just takes in one value. And let's also print it out just so we're consistent here. And let's see what happens. And here we are. Let's see. It called our constructor, and it initialized one of the values here, okay, to 1 here. So we got 1, 0, 0 for this constructor that was called here. Now let's just play around with this a little bit more. Let's say I have these fields here, and let's go ahead and just play around with them here. Say I don't explicitly initialize the field, so they're just going to take in their default value. So again, everything is just not a number here. Okay, so again, these are just some things that we might want to consider here, making sure that all of our fields get initialized here. I'm going to change it back to something more proper that we'd probably want something like this in the D language. And let's actually, where I would actually use this in practice is I say this.x, or again, I could just say x equals y equals z something like that, equals the value, just to show you another syntax. And this is where we might want to actually use this type of constructor for the vec3 type. Initialize all of the fields to the same initial value as a shorthand. Okay, something like that here. This is just a shorthand for a vec3. Okay, now let's put together some of the other things that we've learned here. And let's say for our vec3, maybe we have some hidden value here. I'm just going to say const float w here. Okay, so let's go ahead and let's try to run this here. And it seems to work here, but we should modify our print function to write out everything. And let's make sure that we write out w here with another comma. And let's see what the value for w is. Again, not a number here. Okay, that seems fine. But what if we make this a mutable value? A mutable float w. And again, same thing, where we can use these qualifiers here. But a point I want to make with this example, when we have some of our quantifiers here, like immutable or const, while they're still picked up in the fields, is in our constructors, we do get the opportunity to initialize them. So here I could say this.w equals, say, 1.0f, or in this one, I could also initialize it to that value. Okay, so when we have a field here that's immutable, the constructor is the one place where we can modify it. And we can only modify it once. So if I try to come down here and say, well, this.w equals, 7 or something like that, we will get an error here. Okay, well, there is a previous initialization of an immutable field here. Okay, so just something to keep in mind in our struct constructors. So with that said, folks, that's all there is to it. And that should get you started with working with the constructors in struct. Again, if you have more interesting initialization that you need to do, again, you can do things like whatever initialization you need to do. For a simple type like vec3, you might not actually need this. Again, it just depends on what you're doing. So if you have some abstraction, say, where you're loading a file, you might actually do a lot of that loading the file, setting up and counting how many lines there are, and so on, and setting various fields in that manner. All right, folks, so with that said, as always, thanks for your time and attention. If you want, you can check out my page, courses.mshout.io, and check out the Dlang series here and follow along and track your progress for free, as always. And again, thanks, folks. Hope you're enjoying this series. And let me know if you have any questions about structs. Again, they're probably a little bit different if you're coming from, say, a pure C++ background. Again, because of that distinguishment with value versus reference type. And eventually we will talk about classes after we fully covered structs and a few other topics. So again, stay tuned for that, folks, and we'll see you in the next one.